Hi everyone, we're going to use the principle of mathematical induction to show that the given statement is true for all natural numbers. Basically, this is a geometric series, which this is your first term, second term, third term, and this is your nth term, and this is your sum. Alright, and so we're going to do it the same way we did the arithmetic ones. We're going to check for condition 1, where n equals 1, and when you plug in 1, it should equal my first step into the sum. So when I plug in 1, I get 2 to the first power minus 1, and that gives you 1, which does check. Then we're going to check for condition 2, and this means if it holds for some k, then show that it works for the next term, which is k plus 1. So I'm going to write, I'm actually going to get rid of this real quick, because I think it's in the way. Alright, so we're going to write this with k, 1 plus 2 plus 2 squared plus dot 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 plus 2. And the way I say this is I'm going to say little k minus little 1 equals 2 to the k minus a big 1. Just be clear, because when I'm teaching my students this, they get the little 1 and the big 1 confused. So now we're going to check for the k plus 1. So I'm going to copy this sequence down. 1 plus 2 squared plus dot 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 plus 2k minus little 1. And I'm going to write the next term. So what do you think the next term is going to be? If you don't know, what we're going to do is just write 2, and everywhere there's a k, put k plus 1. And when you simplify that, you're just going to get 2 to the little k. And it makes sense after doing some, you already did sequences in series, that, you know, the k minus 1 means the previous term, so the next term's k. The term after 2k would be 2k plus little 1. Next would be 2k plus little 2, 2 to the k plus 3, and so forth. So that's how that works. So the sum would be now 2 to the k plus little 1 minus the big 1. Okay? Now this equals 2 to the little k minus the big 1 plus 2 to the k. So now here's the rub right in here. This is where the students get confused. I have 1 here and 1 here. I have 2 times 2 to the little k. I have 2 of these. This is like saying x minus 1 plus x, if x were 2k. So that would be 2x minus 1. But my x happens to be what? The 2k. You also need to know that 2 times 2 to the k equals 2 to the k plus 1. And if you don't, just plug in 1 here. If I plug in 1 for k, I get 2 times 2. Plug in 1 on the right side, I get 2 squared. Or you can plug in 2. If you plug in 2 for the k, you get 2 times 2 squared equals 2 cubed. So they work. So once we get established this part, minus the big 1, I'm going to write this as 2 to the k plus 1, because of this, minus the big 1. And now it matches here. And we have proven which is what had to be proven. Condition 1 and condition 2. Now the next 3 videos are very similar to this, so we're going to go a lot faster. They're all geometric. Then after that we're going to do much more complicated ones. Thank you and have a nice day. Bye-bye.